Thanks for coming to the seminar series finale of this semester. We'll be hearing a lot about data science, machine learning this semester, and it's appropriate to hear about the ethics in data practice at the end of the semester. And our speaker today, Dr. Tom Powers, many of us know him very well. He's associate professor in philosophy and in the Biden School, and he's the director of the Center for Science Ethics and Public Policy. He's a truly interdisciplinary and collaborative scholar affiliated with a long array of organizations on campus. I have to read this. The Delaware Biotechnology Institute, the Data Science Institute, the Social Technical Systems Center, the Center for AI Excellence, and the Center for Autonomous and Robotic Systems, OITUD. And his research focuses on ethics information technology. So without further ado, please join me to welcome our speaker today, Dr. Tom Powers.
Thank you all for coming. I was having this conversation with Salim just earlier about my slightly more famous competitor this afternoon, Dr. Anthony Fauci, who will begin speaking at about 4:15. So if anybody gets up to leave, I will not begrudge you at all. I think his audience is probably well deserved. So, and I really appreciate you being here on a Friday, and I hope that I have something interesting for you to think about. And I am going to spend some time in the end, or reserve some time to try to generate a discussion about something I know very little about. Almost everything I know about ethics and geography, I learned from several conversations with Xing and by looking at a couple of interesting organizations and reading a little bit in the literature. So I'm not a specialist by any stretch of the imagination in the ethics of your field. But primarily what I do is ethics in science and engineering. And so my focus is mostly in the last decade or so on information technology, but as you're going to find out in a second, I also teach courses in particular that are focused on engineering and the environment and a variety of other fields. Okay, so this is the outline for what I'm going to have to say today. I have a little bit to say about AI in the classroom for a number of reasons, one of which is that I was called into a committee that the provost charged back in May, and you all remembered last year was the public release of ChatGPT, and faculty all over, especially in the humanities, but really all over, were really panicked about the use of large language models to produce text, not i.e. produce essays for classroom use. And so that committee has been working for a while, and I have a little bit to report about that. But the bulk is really going to be about research. So AI and how it has complicated the topic of research misconduct, which you don't know much about. I hope you'll leave today knowing a little bit more about research misconduct as the United States funding agencies understand it, which is very important because not only do they hold the purse strings, but they punish you if you run afoul of the rules of research misconduct. And AI does make it a good bit more complicated than I think most people would have anticipated. So I also have to have some things to say about other research ethics, things that the federal government doesn't seem to be too terribly concerned about, but are still very important and discussed in this body of literature known as research ethics. And then finally, I'll end with some puzzles in philosophy that hopefully inspire you to think about your own field. And really, this talk has dual purpose. Of course, I hope you learned something from me about research ethics and AI, but I'm really interested to find out what the burning issues, ethical issues are in your field. So, so I'm cheating. No way. I won't record any. I won't hold any of you to it, but I will acknowledge you, like quote you or something. Okay. So just a little bit so you can know a little bit more about my background and what I teach. Every spring, in other words, right now, I teach a course that's required for the ECE and ELEG degree. It's a little bit misleading because this title, Ethics and Impacts of Engineering, would have you believe that it's really about all of engineering. And what I really focus on is information technology. So we talk in that class about privacy and intellectual property and safety, and robotics and autonomous systems. And then at this point of the semester, we're trying to take some sort of big picture topics like what's the role of information technology in improving democracies or making problems for democracy? What is the role of the designer of a technology in being accountable or being responsible for failures of technology? So it's a fun course, and I have to say, every semester I learn a great deal from my engineering students. It's a real treat. As some of you may know, I teach environmental ethics every semester, and it has a graduate component to it. Usually anywhere from 2 to 10 graduate students take that course along with about 25 undergraduates. And lately, last 4 years, I've started teaching in the fall this graduate course called Ethics and Data Science and AI. Started out as an experimental course, as all graduate courses are supposed to do, and it grew. It was first 10 students. I was a little bit worried that it wouldn't fill, and then the next year it was 20 students, and I thought, oh, that's good for a graduate course. And then the next year it was 37 students, and I thought, oh, that's a little bit too much for a graduate course. And then the last time I taught it, I had 62 graduate students. So it no longer was a seminar, obviously, and I think I'm going to have about the same in this coming fall. So I have to think about how to teach this course. And any of you faculty who might want to do a guest lecture, you let me know, because that's one way to handle the wonderful problem of having lots of students. So occasionally, I still teach research ethics graduate seminar, which was originally funded back in 2009 by an NSF grant. The first NSF grant that I won as a PI, that was only my second submission. So I thought, oh, my success rate is going to be 50% from here on. Well, naive, but it was a really interesting course to teach, in part because it consisted of a seminar during a semester, for a whole semester, and then there were sort of outreach activities for these graduate students to do around the topics that they had studied in the course. And we paid this. How many graduate students are there here? So we paid graduate students, or the National Science Foundation paid graduate students $5,000 to talk to their peers about. So if I could have that money again, I would do it in a heartbeat. It was great to be able to fund graduate students with a little bit of extra money for them to go out and talk about research ethics and engage their colleagues. So that's what I do by way of teaching. Now a little bit about AI in the classroom. This is not going to be my main focus. As I mentioned back in the spring when ChatGPT became a thing, and students, especially my engineering students, were way ahead of me in learning how to exploit its abilities. Many of us were worried about plagiarism in the classroom, and we were also worried that students would not, in effect, learn things that they needed to learn because they were just asking ChatGPT to write a summary or write a draft of a research paper or something like that. The other de-skilling worry is on the other side, namely the de-skilling that would occur if we banned the use of AI in the classroom, and students went through 4 years here at the University of Delaware, pretending like it didn't exist, graduating, and then finding out, oh, there's this world in which a lot of people are using large language models, including people in law and people in medicine and people in industrial science, et cetera. So there's a sort of two-part worry about de-skilling, and we had to address that very quickly. So at the University of Delaware, what do? You form a committee. All right, so everybody should hopefully become familiar with this committee, the Artificial Intelligence for Teaching and Learning at UD Committee. And the preposition is very important. It's for and not against. So the idea here is we're trying to figure out how best to integrate various AI tools in the classroom. And this was, much to my surprise, a committee assignment that started about a year ago and lasted during the summer. We met during the summer. Faculty do not like to meet in committees during the summer, and we have continued to this day. So this link should be live, and I've shared my slides with Salim, and certainly you can have them. You can learn more about the work of this committee if you'd like. There are about 20 or so faculty and staff on this committee, and graduate student representatives. So we're trying to figure out what to do in an era in which people are still a little bit apprehensive about large language models in the classroom. So a little bit what we've figured out so far. This is very, very brief. Again, these are reasons for continuing to develop syllabi around AI and use tools in the classroom. Some of this is fairly obvious. You have to do it in such a way that it actually improves educational outcome or improves your educational effectiveness. You want to be transparent with students about your use as an instructor, your use of AI. There will be, I think, very soon, a pretty big temptation to use AI as a grading tool. And so if you're going to do that, you have to let students know. Likewise, you have to let them know on syllabi, you can use the tool for this kind of assignment. You may not use the tool for this other kind of assignment. So these are just preliminary considerations and guidelines. There's a lot more that you can see if you go into that website. My hope is that, well, my partial fear is that this committee is going to last forever, or last as long as AI is influential in the classroom, which may well be forever. And my hope is that faculty like myself eventually do not serve on that committee, and new faculty come and serve on the committee, and students as well, because their point of view is, of course, important. So my main focus today is AI in research, or AI in the lab. And I want to start out with a laundry list of ethical issues in research. The ones in red are what are known as the sort of pillars of research misconduct. The ones in black, right now, this list, are fairly traditional other issues that the federal government does not generally have oversight over. And if you run afoul of one of these, if you put somebody as an author on a paper and that person didn't have any contribution to that paper whatsoever, your colleagues may think less of you, but the federal government isn't going to get involved in. So one of the things that I find interesting is that the AI makes both the issues in red more complicated and expands the list of things in black, the things that we have to worry about that the federal government is not going to have oversight concerning, but that still are important ethical issues. And I am interested to learn what geography might add to that list, right? And so I have already an inkling of some things that are relevant and important, but I'm here, as I said, to learn from you. So a little bit about research misconduct proper. I had to reread the history of the development of these three definitions. I had forgotten that the initial controversy had reached the eyes and ears of Congress back in the late 1970s. So primarily through NIH funding, there were some fairly high profile data fabrication cases. Representative Al Gore at that time in 1980 was the first to call a committee hearing about what then was, not even called research misconduct. They didn't have a name for it. So these cases were studied by that committee, and they sent a recommendation to the NIH, and the NIH formed this Office of Research Integrity. This is now lasting years. Quite literally, those words verbatim took 20 years to decide on. Now you might say, well, what is that? Like about 9 months per word or something like that. So what was controversial? Well, they knew that they were going to apply these to universities, all recipients of federal funding. And they knew that when they did that, the universities were going to have to understand what they meant by research misconduct, because investigations would often begin at universities. And then if the NIH, and specifically the Office of Research Integrity, wanted to get involved, they would have a separate investigation. So they wanted very, very short definitions of these bad things that you're not supposed to do. But this is verbatim what they came up with after 20 years. You might say, not very expansive, not really described in depth, but that was the result. And these 3 definitions of research misconduct: fabrication of data, falsification of data, and plagiarism, were then very quickly adopted by all the federal funding agencies, maybe because it took them so long to come up with a definition, but everybody said, okay, this is fine. Now we're going to use this federal definition and we're going to enforce it. In particular, the NIH, some of you may know this, the NIH, if a researcher is found guilty of one of these 3 things, they publish your name in the Federal Register, and depending on the infraction, they disbar you from funding for a period of time, 3 years or 5 years, which is mostly that's the axe for your scientific career, right? So not only is your name in the Federal Register forever, but you don't have funding. And so so they take all of this stuff very seriously. And the research ethics course that I teach on occasion spends a great deal of time trying to figure out what exactly is fabrication of data, what exactly is falsification of data. We spend a little less time on plagiarism because it seems to be more clear-cut. May in the future, as I'm going to point out with large language models, may not be clear-cut. What actually counts as plagiarism? So we're going to talk about this again. We're going to see this list in a little bit when we try to figure out why AI complicates these definitions. But I just want to point out to you that there are, as that list in black would indicate, there are a bunch of other things that research ethics concerns, sort of what sometimes are called questionable research practices, that you can get guidance on. This Committee on Publication Ethics is primarily concerned with the sort of business end of submitting a manuscript, reviewing a manuscript, accepting a decision to publish, accepting data for readers having access to your data. So some of these things in red are already, as I'm going to indicate in a little bit, already becoming quite critical issues when we think about the addition of AI. So in particular, we're going to see the response of 2 very important journals, Science and Nature. The journals are a little bit unsettled as to what to say about text that's produced by a large language model. Initially, they came out, Science in particular came out and said, no way, no how, we don't want anything that was produced automatically in a manuscript. And then there were certain examples where, you might say, well, that's not so unreasonable. I'll give you an example of this. So if you have, as is typical in scientific papers, if you have a methodology section, and the methodology in one particular experiment was the same as the next, you have different results of different experiments, but you have 2 different papers, you might want to repeat in large part the methodology section, or at least chunks of that text. That used to be thought of as a form of self-plagiarism, but still permissible. You can just say it's same methodology. What's the big deal? So there is a worry that people submitting manuscripts will capture parts of a scientific paper that they didn't write, but that no other identifiable person wrote as well. So they won't exactly be plagiarizing somebody else, but they'll, ask an LLM to produce a little bit of text. Maybe they'll produce this text because they feel more comfortable with the language produced by a large language model as opposed to the language that they would use. Whatever their motivation is, it'll be very difficult to figure out how you cite that automated contribution to your paper. It's doubtful that any scientific journal is going to allow a large language model to become an author, but I have an example late in the slides, which, looks like an AI created a scientific paper. It's a very strange example that I discovered this summer while I was at a DARPA workshop. So obviously, and especially for your field, data and reproducibility, now that we have access to massive data sets, some of which the analyses are run automatically, and we don't really have the old-fashioned way philosophers of science used to think about it, the scientists contemplating a hypothesis and then going out and gathering the data themselves and then testing the hypothesis against the data. That's sort of a different way of thinking about science. And now we're in the era of what is called discovery science, where you have massive amounts of data and you run tools over the data and discover new things without thinking about a hypothesis in the beginning, right? So the tool does the work as opposed to the scientist. So now just to return a little bit to this definition problem with research misconduct, I have really three different cases to talk about. One of which is not certainly peculiar to academic science, namely the use of synthetic data sets and how we're going to deal with that given the very basic and austere definition of data fabrication in the original definition. In other words, if you look back at that original definition, it just says you can't report data that were made up, right? And it appears that that's exactly what a synthetic data set is. It's a data set drawn mathematically from an actual set of data where the patterns are preserved by some sort of mathematical analysis that I don't understand, but it's not de-identified data. So synthetic data are not de-identified data from data of human subjects where, where it would normally reveal their identity, right? So unless you know the mathematical transformation, you can't go from the synthetic data set back to any real data set involving real people. But as we're going to see, at least there's some indication that synthetic data will be used increasingly in science because data are getting expensive. And if you can train a model on synthetic data, then why not do it? So another worry that again seems to run afoul of this definition of falsification of data that the federal agency uses is in curing data, or what we do with missing data. And I have a very small data example to show you that I actually use in my class. It happens to be in the medical field. It concerns brain injury, traumatic brain injury. And the paper is arguing for a technique of supplying missing data, which may be familiar in geography. I don't know. It's known as multiple imputation. I'm not sure. Apparently, it is now the part of a lot of softwares where you can perform multiple imputation without doing the calculations yourself, but it is a way of supplying values that are missing. Okay, and again, it seems like a good thing to do, and the paper indicates that it is a good thing to do, but it looks like it runs afoul of the definition of falsification data. And then we'll discuss just briefly, again, this problem of using a large language model to supply some text or even to review a manuscript for a journal. I just read, I think something came out this week about journals, certain journals indicating that now 20% of their reviews have text which look like they came from a large language model, which is a little bit bad. So here is, I'm not sure how much faith to put in this figure. This organization, Gartner, is a sort of a big data science and AI company that makes a lot of projections about where the field is going. But they say, at least, that by 2030, the amount of synthetic data that are used to train models as opposed to real data is going to be huge. And that's in part because of the cost of data, but also the ease of generating synthetic data sets, again, from data sets that originally correspond to some reality in the world. They're representative in a sense, but they're not the real data. And so it's hard to know whether this projection, maybe this is hype, maybe they're trying to sell synthetic data sets themselves, one never knows. But if it's the case, then we'll increasingly have to answer this question. What's the provenance of the synthetic data set? How does it represent real things in the world, if at all? And is there a danger that when we train models with synthetic data sets, that we'll always remember which are the synthetic data and which are not synthetic data? So if you get that mixed up, you could very easily run afoul of some.
When did this come out, though? It says 2020, 2030. What's the date of this?
This was, I believe so. It's linked in here, and I can tell you I think the date is just off of here. I believe that it was 2021. I think that's right. But I will, when we're done, I'll click on the link to this and you should be able to tell. So, you know, again, you look at this kind of thing and you say, well, it could be true in some fields, not in other fields. I do know that a lot of the interest now in synthetic data sets come from the cybersecurity industry. So for instance, a bank is trying to simulate attacks onto its system. And it's apparently quite effective to do that through synthetic data. So they can generate all kinds of scenarios in which somebody is trying to enter a server that the bank owns. Gaming is also highly useful for synthetic data sets. In January, I was at a workshop at NIH. The NIH knows that synthetic data sets are being used in proposals to the NIH. Now, these, again, relate to human health. And I was very surprised to learn that so far the NIH doesn't have a policy on the use of synthetic data. Some drug companies have submitted proposals to FDA to get drug approvals with synthetic data. And so you think, hold on a second, this is, there are real people with real diseases, and we want to employ real therapies to them, but we're training these models with synthetic data. That seems to be a little bit dangerous, right? But part of the reason that we were there at NIH was to try to figure out what should the rules be about the use of synthetic data. And in particular, if somebody's provided real data and that data becomes or is part of a synthetic data set, do we have to tell them, as much we would in other ways when we're reusing that data, that now their data are being reused? Yeah.
So you were saying that you want to hear about our field, maybe how things are done, and I thought I would mention this, maybe it's irrelevant.
Yeah.
I personally made synthetic data myself in many occasions, like.
Right.
For some simulations, we didn't have enough data about offshore wind, let's say. So
Right.
we had a simulation, but we didn't have real data. But
Right.
what we had was an error function from observations over land. So
Mm-hmm.
we created simulated synthetic
Right.
time series of whatever offshore wind speed, etc. And we were able to reproduce scenarios, like scenarios of possible observations that had the same error behavior, but they were not real.
Yeah.
And this is done a lot, like hurricane, there's
Mhm.
tons of synthetic data on hurricane paths for future and past, and so those are totally legitimate
Yeah.
synthetic applications that.
Right, yeah.
In case you.
Yes, and no one would want, I mean, I think it'd be foolish to say, well, this is a really powerful tool. It can be incredibly beneficial, but we want to ban it, right? I think one of the difficulties, if you remember back to that definition, is that anybody who looks at a report going into NSF or DOE or something like that has to understand that there's a difference between the production of this synthetic data using the error tools that you use versus making stuff up, right? So obviously the fabrication of data rule was directed to, or you might say against, science that never happened, right? So people inventing data because they didn't have time to go back out in the field, or the data were corrupted for some reason, and you just say, oh, I'll just scribble it in. You want to be able to punish that kind of activity and not in any way even dissuade the other kind of activity. But it will invariably become an issue when somebody's not aware, especially people who are reviewing these things, not aware of the difference, right? But thanks for that. I mean, that's another. I did not know about the hurricane data example, but there are all kinds of very useful, important synthetic data applications. Okay, so I mentioned about curing of data. Again, this is you probably work on data sets that are slightly larger. This involves 20 patients. These were patients with traumatic brain injury, and they were trying to figure out, the point of the paper is what's the best technique to cure the data supply missing values when you have them for whatever reason. So they were particularly interested in this COWAT test, which is a reading and word association test. They wanted to find out how people with traumatic brain injury did on this test. So they pretended that they lost the data from 8 patients, okay? And so one of the ways in which you deal with missing data is you just keep it missing. This is known as the deletion technique, right? And so the deletion technique where the calculation of the mean value for this test would, with all 20 participants, normally have been 39, and the standard deviation of 13.67. With the deletion technique, you get not such a great result. With single imputation techniques, the first one is mean imputation. You take the mean of the values that you do have. The second one, use a single regression equation, and you calculate the value, and you put that in for the missing, so-called missing values. You still get not so great results, right? So this is part of what this paper is arguing about. Both the deletion technique and the single imputation techniques are not so great. Much better is the technique known as multiple imputation, where you take several, in this case, 5 regression equations, and you pool them at the end. And what you come up with in multiple imputation is a score 38.93, which is pretty close to what the score would have been had you not, gotten your eraser and deleted this. And also the standard deviation is fairly close. So this is an obvious example of, scientists supplying values for missing data from a calculation. It's not an AI example. This is a basic data science example, where the authors are saying we should really do this because, again, these are brain injury patients. These data may lead to some particular therapy. We want the results to be as accurate as they can be. But again, if you look at that old definition, which took them 20 years to develop, of falsification of data. It looks like that's what you're doing precisely, right? So you're supplying data points where you otherwise didn't have them. Now, I think the real risk of this is not in some quite innocent case where you say, for some reason, we had 8 patients who weren't there to be measured on Wednesday or something like that. I think the real danger in this is to have missing data, to know what result you want, and then say, well, let's see. On Monday, I'm going to use the single deletion technique. On Tuesday, I'm going to use, mean regression, so on and so forth. And then decide what your technique is going to be based on the result that you want to get. And so, that's a problem, right? That looks like a certain kind of scientific dishonesty because you're sort of prejudging the way the data now imputed, supplied by you, ought to look. So another area that somebody's going to have to figure out a little bit about plagiarism. I'm sure that many of you know this already. Plagiarism, again, is one of the rules of research misconduct that you don't break. It is really much broader than people normally acknowledge. Namely, it's not just using somebody's words without attribution. It's also using somebody's ideas. So if you had a conversation with somebody and then you wrote it down and submitted it as a manuscript to a journal, and you didn't acknowledge that person, you would in principle be plagiarizing them. It's just that words that are in actual text are so much easier to discover as versions of plagiarism, right? But if you use somebody's ideas without attribution, it is also plagiarism. So a different topic, but related topic, is the notion of copyright. So somebody has copyright in written or sang text or plays or whatever it happens to be, as soon as they are fixed in a tangible form. So you don't gain copyright on your idea for a play with 2 star-crossed lovers. You gain copyright when you write down Romeo and Juliet, right? When there's a piece of text. But the reason that I think that they're interestingly connected is that there is now this ongoing lawsuit against OpenAI. New York Times a couple of months ago joined this lawsuit. The people suing OpenAI say, look, ChatGPT was trained on our data. And the New York Times says in particular, ChatGPT was trained on all of those articles that we allowed your bots to scan. And we are not credited. So we're not, there's no acknowledgement that the outcome of a particular ChatGPT query is something from the New York Times, the Washington Post, or any of these other people who have complained. So the real issue that ties copyright and plagiarism together is, how do we find, or will we find, an identifiable victim? In other words, somebody who has been copied, either in the plagiarism case without attribution or in the copyright case, where there is a previous copyrighted text that has been copied in some way. So the interesting thing about this, of course, we don't know yet in most cases how even to acknowledge that you got something legitimately from a large language model. And it looks like the defense of OpenAI will be fair use. So how many of you heard of the doctrine of fair use before? It's incredibly important. I put materials on Canvas that are copyrighted materials, some of which might normally be behind a paywall, but fair use allows me to do that in teaching. So fair use is sort of an exception to copyright, and is an exception to copyright, and it allows you to use copyrighted materials for all of the following purposes, including to reverse engineer software. That's part of the fair use doctrine. Will OpenAI succeed in claiming fair use of all of the internet, which is essentially how ChatGPT was trained. That is the question before the courts. But if they decide the copyright case in a certain way, my hunch is that plagiarism cases will also be decided in a similar way. Namely, you don't need to find an identifiable victim to have violated copyright, or you do need to find an identifiable victim related to a particular string of text that says, aha, now I have a case of a copyright violation. Okay, so now to get on to move beyond research misconduct, if you'll let me for a second. Here's a little bit about authorship. Science, when was this? Back in February of 2023, published this piece saying, we don't really know what we're going to do, but our first impulse back in February 2023 was to say, no AI generated text. Obviously, if you're a reviewer, same thing, please don't do this. Nature had a much more nuanced response. And this is just the very first part of a really quite long and interesting, I have to say, interesting website that Nature has put up about the use of AI. And as you read through there, what you will see is that Nature is taking this kind of let's wait and see attitude, right? So they right now want you to declare if there have been any AI generated images in your manuscript, if there's any AI generated text, so on and so forth. They have some language in this which allows them to be flexible in the future, let's put it that way. So the interesting thing that appears to be happening is that journals are not taking one uniform policy about AI in manuscripts or in reviewing. Whether that's going to stand, I have no idea. I mean, obviously, if you've generated a manuscript and you've used AI and you'd like to submit it to this journal, but they say absolutely not, then you're going to go journal shopping, I guess, or shopping for a journal that may be kinder to what you've done. So now you knew we had to say something slightly political about AI. What about these bigger picture issues with AI and our civic and political life? Well, this is part of what I teach in this graduate course. There are, of course, corporate interests in having access to your data, but also eventually having you subscribe to their AI tools. There are government agencies that are buying your data where they couldn't normally, at least according to privacy law, have access to it. So this article in particular from the Brennan Center revealed that the usual suspects, National Security Agency, CIA, FBI, have been buying data about us that they are forbidden by law from gathering. So they buy it from companies who gather it for them, like Verizon and AT&T and everybody else. So that's quite shocking. So these are just some, popular media. They're not scare tactics. They are designed to get our attention to the sort of overt political implications of AI and the massive amount of data on us that the government would like to see. So when it comes to this so-called other category, so we've moved beyond research misconduct, what are all of the other things that AI can require us to grapple with that count as an ethical issue? So here's my short list. This is the topic list for the course that I teach. Informed consent, I'm assuming at least in geography it can be, depending on the kind of data that you're using, is an important issue. You got to, especially human subjects, you have to find out whether they allow you to use your data. Related to that, of course, privacy. There are a growing number of readings across the human health and the environmental fields that explicitly acknowledge that AI is making their lives more difficult, and so on and so forth. As you see, as we get on towards the end, we have these very big picture discussions. Where is this taking us all? Is this a development in our technological lives that we really want, that we're in control of, that we understand? And so I want to end a little bit with some of those discussions, because I think they're a little bit provocative and people have opinions about whether AI is a good thing or a bad thing, or yes, good and bad. So let me sort of provoke you by this, taking a quick look at this paper that I discovered this summer. So this is still on archive. These three scientists are all from Carnegie Mellon, and what they report as having done is training an AI that they call agent throughout the paper, and they asked it to do several things that scientists normally do. And in the most interesting case, they, as they say here at the very bottom, they had it perform a successful catalyzed cross-coupling reaction. In other words, it ran the robot that did the experiment. It was a wet lab experiment. It gathered the data, it wrote up the results, and if it was the old-fashioned days, it would have put the paper in the envelope and put the stamp on it and taken it down to the post office. In other words, this was science done by an AI agent. So as I mentioned, I learned about this at a DARPA conference, and DARPA was really interested in this for one fairly obvious reason. It may be possible to do science now 24 hours a day, 7 days a week, without the explicit involvement of scientists, in other words, human beings. You feed in some instructions, go survey the literature for open problems in chemical catalysis or something like that. Figure out what the proper experiment would be. Run the robot in the lab that does the experiment. Gather the data, analyze the data, write up the data. So that's really mind-blowing. And some of you may be thinking, oh, I thought I had job security, but now I'm not so sure about this. So just to assuage your fears, or maybe to even make them even worse, this is already going on in fields such as law. So for instance, it used to be that when you're right out of law school, you spent the first couple of years reading a bunch of boring cases and writing summaries and doing work that no young lawyer would want to do. And now it's primarily done by AI. And companies are actually selling these analyses of cases and risk, et cetera, to companies and saying, no, we didn't have a person do this. We had an AI scan all of the relevant case law and statutory law, et cetera. So I think this is really provocative. As a scientist, you may be worried. As a non-scientist, I say, this is really interesting. What if science can primarily be done now in an automated way, including the experiment, including the analysis, including the write-up? Or I guess we could imagine, when will the first AI Nobel Prize be, right? So when will the first agent win a Nobel Prize? That would be really interesting. So just a little bit about some work that I'm doing right now. I'm on this NSF grant, which Kathy Wu here is heading up at the University of Delaware on an open knowledge network. One of the things that we're trying to figure out, especially I'm trying to figure out, is that can you exploit public information about the social determinants of health, about a variety of biomedical and health data that we get from published results? Can you learn about disease states and their relationship to what people do in their daily lives and potential therapies, without at the same time increasing the risk to them? And so some of you who've worked with health data will know it's, the apart from national security data, the most highly protected class of data. So you cannot simply publish health data of people. There are very serious penalties for doing that. Everything has to be anonymized and very carefully controlled. So this is one of the things that we're trying to figure out, namely, how can we increase the usefulness of all of this public health knowledge without increasing the risk to people. So I want to, I was going to do a little bit of something about the trolley problem. Let me skip over that because you've probably heard of the trolley problem in your sleep like I have. I want to sort of switch to end up, before we get to the geoethics, it's worry that I've had for quite some time about social media. So sorry this is cut off, but this is a publication of the Wall Street Journal where they got a hold of something called the Facebook files. Some of you may know about starting in 2018, there was a big data breach or borrowing, or it depends on how you look at it. Somebody, a whistleblower, got emails from Facebook leadership, and it revealed some really fascinating things. You can still go to the Wall Street Journal, and they have a treasure trove of emails from Facebook executives. So one of the most interesting ones involved a plan that was announced by Mark Zuckerberg. He was worried, as all of the leadership at Facebook was worried, whatever, 10 years ago, that people were spending less time on Facebook, that they were just, popping in to see if their friends had said anything, that they were not really engaging with the material. And so their eyeballs weren't on Facebook pages for long enough, and that means they're losing money, right? Because Facebook gains advertising revenue by being able to claim that people are really spending a lot of time on Facebook, et cetera. So here was the remedy. Let's promote what Mark Zuckerberg called healthy user engagement at Facebook, right? So let's change Facebook so that the users are really spending more time in Facebook. And the use of the word healthy, that's not my language. This is explicitly what he said. So here's what they did. They tried to figure out how exactly you boost or increase meaningful user interactions on Facebook. And what they did was to change the algorithm so it weighted certain newsfeed activity, reshares and comments, more heavily the more people did it. Okay, so if you saw an article that a friend of yours shared on newsfeed and you shared it and you commented on it, and then it sort of had this, this momentum. The more people shared and commented, the more it would pop up at the top of anybody's newsfeed. And then one day, somebody from BuzzFeed contacted a friend working at Facebook and said, we've noticed there's this really weird traffic from BuzzFeed. Our most vitriolic, angry, ideological posts are going directly to Facebook pages. So in other words, the traffic they were getting between BuzzFeed and Facebook was highly angry reshares, comments, what some people, nowadays would think of as hate speech. That was well reported within the company. They understood that their algorithm was boosting engagement, but it wasn't healthy engagement. It was angry, pissed off, I'm going to go do something bad engagement. Facebook, and this is all documented by the Wall Street Journal, Facebook looked at that data and they said, well, okay. So even though the engagement wasn't healthy, it was getting eyeballs on Facebook pages for longer. And so they said, it didn't exactly do what we planned to do, but we're going to keep it. And to my knowledge, that's still the way that newsfeed runs. Right? So your reshares, your comments are boosted to the top to the extent that everybody else gets. Now, the algorithm didn't say, look for angry words or something. Just so happened that the ones that were reshared, retweeted, or commented on and on again were the angriest messages. So that worries me about the future of corporate AI. I think they're this isn't just to beat up on Facebook, but I just think they're constantly compromised by the profit motive, right? They may say, oh, social media is here to connect the world and make us one and all this kind of stuff. But at the end of the day, they got to worry about share price and they've got to worry about eyeballs on their website and stuff like that. So I think they're constantly compromised. So I thought I'd end with a question to you all. So as I was preparing for this, as I said, I went to look at several different, very interesting organizations, one of which is this International Association for Promoting Geoethics. They've got a really nice list of articles relating to, a lot of them relating to the pandemic, about contact tracing, about privacy, about informed consent for health-related data used for purposes of combating the pandemic, et cetera. So the other thing that I took a really quick look at was an article by Nelson et al., in which the authors said something which I found, I guess, either inspiring, but at the very least surprising. And that is that they were going to focus on empathy in doing geographical analyses or geographical science or GIS, right? So I thought that's a really, I hadn't thought about that before. So in philosophy, I'll tell you sort of the history of what we think of when we think of empathy. Adam Smith, famous author of The Wealth of Nations, wrote another book in the late 1700s called The Theory of Moral Sentiments. And Smith, in The Theory of Moral Sentiments, has this very elaborate theory of ethics as empathy. And now remember, so empathy and sympathy are not the same thing. It's not suffering with somebody. It's simply taking the point of view of somebody else. So Smith thought that almost all ethical worries could be resolved by what he called an ideal observer who took the position of the person who they obviously weren't, but they were affecting in some way. And so this article, I found this really very interesting. It said, look, if you're a geographer and you're using somebody's data, you have to take their point of view about your use of their data. If you're mapping their neighborhood and you're saying, you know, how horrible crime is in their neighborhood, you have to stop and say, what's their point of view about this use of our data, and so on and so forth. So I'm not sure how this sort of ethics of empathy could be formalized in any sense, and maybe you all can give me good examples of how you would stop and say, well, here are these data subjects. I'm about to publish this. I've got this great data on them or about them or their housing values or their flood risk or whatever it happens to be. And now I want to empathize with them before I publish this. So as I said, I thought this was very interesting, novel use of the concept of empathy. It goes back, you know, in philosophy, goes back hundreds of years, but I think has some actual promise. So that's all I have to say. Sorry, I went on a little bit longer than I thought I would go on. And so the question, again, I just want to repeat from the very beginning is, you know, what do you all take the ethics of geography to be? What primarily do you worry about, if you worry about it at all, when you're thinking about the research that you do? So that I open it up to you all to inform me. Thanks.
I mean,
Or you can talk about other
well,
stuff.
regarding this question, it comes from the authors are coming from sort of the tradition in human geography, where there was a sense that, I heard one human geographer say maps are violent objects. I'm like, what's violent about a map? But it was
Right.
about this sense that maps are creating divisions and are subjective to what that is. And so if you are drawing maps, you want to know how the maps will be used. So some of it comes from this sense of the role of cartography in shaping human conflicts and so on. But geographers have also, I should note, engaged quite a bit with the AI field. And there are two books which, if you're interested in exploring this, both were written coincidentally by people at University of British Columbia, and both were published by MIT Press. One is called AI in the Wild by Peter Devon, who's a political scientist, but it's about the use of AI and sustainability. And the other one, which has just come out by a geographer who sadly died very suddenly, Karen Batka, it's called Gaia's Web. And that's
think I've
about,
heard of the
and it
latter
was just
one, yeah,
reviewed
okay.
in Science, and some of you may know her husband, Philippe Lepeon, who visited us and spent a day with us. But it's really, those two are, top-notch books in terms of how digital technologies, data, AI, are, interfacing with geography.
Yeah, so I mean, the concept of violence, when you're saying that, I was thinking, I'm gonna roll up this map and that would be violent. But other than that, there is something to this. So, in philosophy, we've been interested for a long time in the notion of a model, a mathematical representation of whatever it is, some reality about the world. And of course, when you produce a model, you do two things. You tell the truth partly, and you also lie a little bit, right? Because every model is partial. Every model represents the world only partially. So you have to make a decision. I'm going to represent this, and I'm going to leave out that. So I think maybe that's one way of understanding the violence part, and especially if the map ignores your plea for, implicitly, your plea for help or better seawalls or airplanes in a disaster or whatever it happens to be. Yes.
Thank you so much for your talk. And I just want to follow up what you mentioned. I teach Introduction to GIS, and my undergraduate students, there's no prerequisite. So I do not assume they know how to make a map. But what I introduce them to, and I'm sure Jamie, her cartography class, teaches more about that. You can create a map, you can design a map for many different audiences using the same data, right? So you have this population data and how much data goes into different beans and how you choose those beans or categories might result in very different looking map and might serve the purpose. So if I want to show, I want to focus on this neighborhood for whatever reason, and I ask someone, make me a map where your map will show what I want to show, it's possible, right?
Yeah.
But then the ethics, the research integrity, the accountability, that's what comes to play. And I don't believe maps are violent, we make them all the time, but I do believe they are very powerful. Yeah. And like any kind of powerful tool, it comes with great responsibilities. And that's something I hope that our students learn. And I also tell our graduate students that, the integrity, the research integrity is very important. So whenever you are, no matter what kind of data you are using or collecting, always keep that in mind. And that's where I think AI would never be able to completely replace us because, and I have to, that's all the just not my tools, but I just feel like, where's the accountability, right? Like if, as a human being, I am doing something really bad, there's probably, hopefully, there's some accountability in there. But if an agent does something, like who is responsible? If it's completely off my plate, right? Like if I'm the one making the agent do something, I should be held responsible, right? But if there's a world where the agent is doing everything, how does it matter? Should I just send that agent to someone? You know, the accountability, that's really bothers me, and that's what I think our students need to know. Yes, sure, there are tools, that would make my literature review, much easier, right? I don't have to spend weeks. I can do it like, well, it can do it in a moment for me.
Yeah.
But what am I learning from that? Right? So I feel like that domain knowledge and maybe AI tools are okay fine tuning some of the concepts or, or making life a little bit easier, but that domain knowledge, that foundation is very important. And sometimes I feel like students these days, for whatever reason, they're more prone to using it without realizing that they are missing out on the skill sets.
Yeah. So this is, I mentioned briefly in the beginning, this descaling worry. So just to respond real quickly to one of these sort of strange philosophical connections to the notion of accountability. So for a long time, decades, philosophers of mind were under the influence of this paper by John Searle, which argued that AI would never be intelligent and AI can't think. And so let's get over it. And it was, in a lot of ways, it was a very simplistic account of AI. And so fine, it generated some interest for philosophers, but eventually people in cognitive science and neuroscience thought, what are these people talking about? You know, they don't even know what contemporary AI is about. So here's what I find interesting about accountability. If I use a lawnmower on your lawn and it does something wrong, I don't, of course, find the lawnmower accountable, right? I'm the one who's accountable. I'm mowing your lawn. You say, oh, you cut my grass too short or something like that. But AIs make decisions and they make inferences. And it starts to look, I'm not saying it is the same thing, but it starts to look like a human agent in the same sense in which it selects, ignores, prioritizes, so on and so forth. So there are these intellectual functions which appear to be, in the words of the cognitive scientists, multiply realizable. So they're realized in software systems, they're realized in human beings, they're realized in cats and dogs, to tell you the truth. So somebody is going to come along and say, and now I've created an AI that is accountable because, and it's not happened yet, but here's going to be, I suspect, the rationale. I can trace the origin of the decision, so I can explain how it came about. I can interpret the influence of various data sets and how the algorithm transformed them into the outcome. And so I might not be able to ask the machine, you know, do you feel sorry for this or something like that? But it's gonna start to look like the human process of asking for an account. And the human process for asking an account, you know, after some mistake has been made, you call somebody in and you say, what happened? What did you do? Why did you do this? So on and so forth. And even though they're not, you know, I certainly grant they're not the same, it's not the same kind of accountability. It's going to start to look a lot like the same kind of accountability. And once we cross that bridge, I don't know where we're going, because then, you know, for every case of a human decision maker who deploys an AI tool, there'll be this out. Well, you know, I didn't really do it. I mean, I thought it was a good tool to deploy at the time, but it made its own decisions. And so, you know, I'm off the hook. Blame OpenAI or something like that. And that's going to be bad. So I certainly agree. Yeah.
On Zoom also.
Can
check.
You understand? I can check. Okay.
Questions on Zoom? Others. So
I think I'll give you 5 minutes to go zoom into Fauci. Fauci. I really appreciate the invitation. As I mentioned, I didn't start thinking about the ethics of geography until several years ago, had this conversation with Xing, and I thought, there are actually issues here. I would certainly, as you discover things in your own research, or you want to discuss them with me to the extent that you think I can understand what's going on, I'd certainly like to hear about them. So I sort of, when you do the science of, when you do the ethics of science and engineering, you always live vicariously, right? Because I don't have a lab and I don't do science, I'm not an engineer. So everything that you think about when doing the ethics of science and engineering, you've got to learn from somebody who actually does it. So, yeah.
The first thing that, well, not necessarily the first thing, I teach a lot of undergraduates, and I'm not a GIS person. But I tell them when we start doing with the maps, map projections at the beginning, I always show the clip from West Wing on cartography. Do you know that?
I don't know it. I know West Wing quite well,
Yeah,
but
so if you Google the clip on, it's cartographers for geographic integrity, I believe, like society that comes and talks to them. And they talk about the way that the Mercator projection promotes inequity because of how it's designed. And yet that's what most of the students learn when they're in grade school. They see the Mercator projection. And it promotes difficulties in society because it's northern hemispheric heavy.
That's why Greenland looks massive because of the projection.
Yeah, when it's like several times smaller, than like 16th of Africa instead of the size of it. So and they go through it, it's 3.5 minutes, and it really makes an impression with the students about showing how you, I said, we are very geocentric. Because when we look at a map, look right there, where is it centered? It's centered on the Atlantic, right? It's not in the Pacific. So
that's a fascinating example. So I'll tell you, let's just end with this sort of anecdote about concepts and about how we sort of carve up the world. So John Locke, who you may know, was a famous 17th century philosopher, was what we call in philosophy a nominalist. So he thought that there were no real divisions in nature, that nature was, as it were, categorized by our language. So these categorizations were a matter of historical output, but the idea was that human language carves up the world. The world isn't already carved up for us. And later philosophers, especially Hume and Kant, would say, no, well, he's got a point here where we can have concepts that are socially constructed. The concept of marriage, for instance, is obviously socially constructed. But what we want is a language and a set of concepts that, in their view, carved the world at its joints. So if you can imagine, this is a little bit of a meat-heavy example, but you've got this carcass in front of you, and you need to carve it. Your language has to carve up the world, but you want it carved at the joints. You want the language to really separate the world into those body parts that are real and not that we just impose upon us. So that's I always think about that metaphor, because it is a really powerful metaphor. Our language either does or does not carve the world at its joints. Which, for you vegetarians, sorry, I have to apologize for that one. Okay, thanks very much. Have a good week.